Hi everyone, this is an engine channel. Today we are going to assemble this engine. This is a D12 engine taken from this kind of car. The disassembly of this engine is available on the channel. The link is in the description below this video. So I'm starting the assembly. The block has been machined with the main bearing beds bored. The cylinder head mating surfaces and seating for the cylinder liners were left untouched and are in good condition. So let's focus on the main bearing beds. The machinist said that it was just in time that we removed the engine because the bearings were about to spin, and then the block would have been 100% ready for the scrap heap. The block arrived to me yesterday, and now my task is to work with the block to prepare it. Here we can still see some shavings. This amount will come out. Then I'll need to blow out all the shavings, clean all the channels, open up the plugs wherever necessary. Maybe next I'll install the oil jets in place, and then we'll start the assembly, that is, install the crankshaft. The camshaft in this engine is installed in the cylinder head, so there's not much work to do with the block itself. But I think there's no need to replace the parts there. They're installed, just push or release, and so on. The crankshaft, new sleeves and piston assembly are being installed. The pistons are in place and everything is going smoothly. All the necessary parts have been purchased and are on hand. The engine was disassembled about 3 or 4 weeks ago, so it's been almost a month. Well, as we remember, this engine was very dirty inside. I mean, probably the dirtiest engine of all the engines I've ever worked on in my entire practice. So I don't even know what day it is now. I've already been cleaning it, washing it by all available means, using diesel, chemicals, a pressure washer, and a jet type washer. Basically, I'm trying everything I can to get it all cleaned up. I don't know, I'm exhausted, I don't know, I've already spent so much time on cleaning, but I'm telling you, they will never become clean. The engine, I've never had anything like this before. This is roughly what it looks like after using chemicals and after the pressure washer. So here we can't see it, we still need to remove some gaskets somewhere. The old ones, or rather the old sealant, clean up some areas, rethread somewhere and so on. So there's still work to do. We'll be dealing with all of this as we go. That's the scope of work, so let's get started. So next I'll be installing the crankshaft. I prepared the crankshaft and polished it. But first I washed it in diesel fuel because, as I already mentioned, this is the dirtiest engine I've ever seen. Well, there's a lot of this solidified, sooty, burnt residue. So I washed it in diesel fuel, then I rinsed it with a special degreaser, one that actually dissolves oily deposits pretty well. I cleaned all the channels, rinsed everything off the top, blew it out, and also unscrewed the plugs. As you can see, we have these kinds of plugs. This is how it screws in, and there's an oil channel drilled through there. So as I mentioned in the previous video about the engine, about engine repair, there was a lot of buildup under this plug. The dirt was pressed, black and dry. I tried to remove it, but it wouldn't budge. I had to drill it out, basically, turn it into shavings, so to speak, and then blow it out. Conval polished and measured it. It's in the negative, literally by 1/100th, 1 or 2. So you could say the condition is perfect. So after polishing, I brought it here to the table and blew it off again. Now I'm going to close these plugs, set them in place with the thread locker. Well, that's basically it. Next, we print out the inserts, print out the thrust rings, and then install the crankshaft. And let's examine the current state of our oil channels. This is how we shine a light into the channel that's located on the main journal, and we can see the channel is absolutely clean. That is, I've already checked all of them, blew them out, cleaned them with a thin drill attachment, a metal brush, and also degreased everything here. In general, everything is completely ready for assembly. So the crankshaft is tightened. We tighten it to 160 to 170 Newton meters, and then turn it another 120 degrees, plus or minus 5 degrees. The entire crankshaft is fully installed and tightened. Basically, the counterweight here is non-removable, all the plugs are tightened with thread locker, and the whole crankshaft is in place. Next, I'm unpacking the pistons and sleeves, and then we'll install the pistons onto the connecting rods, and then the pistons with the connecting rods into the block. So we can see. So this will be our lightest piston, 5,400, let's say 5,405. And it turns out this is our heaviest piston, 5,443. So that's 33 grams plus another 5 grams, 38 grams difference. The maximum weight difference between the pistons is 38 grams. Well, we can see that this piston, as I already mentioned, has a design with a separate skirt from the piston crown, and the piston crown itself is made of cast iron. That's why it has such a weight, such a heavy weight. Well, considering that, for example, on Mercedes pistons, the weight is 3-something kilograms. And there we have a tolerance of up to 100 grams. If here the piston weight is 5.5 kilograms, here we have a larger tolerance, more than 100 grams. Well, let's focus on a difference in piston weight of 100 grams. Here we have 38 grams, so basically this is within the normal range. So, I've already installed the pistons on the connecting rods, also checked the piston ring end gap. I've also installed new connecting rod bearings, as well as main bearings, all from the Cape S brand. So I've already installed the sleeves in the block, for now, just without the rubber seals, installed them and measured the protrusion of the sleeves above the cylinder block. The sleeve design here is quite interesting, though it may not be very clear on camera. In general, this spot here has a kind of spherical profile. And it turns out that the very top of this profile, the very peak of this sphere, it should rise above the level of the block by 1800ths. I measured all the sleeves and the protrusion is consistently 1800ths. Everything is fine here too. Well, we didn't do anything with the block in this area. That is, we didn't do anything with the cylinder head seating either. The seating for the sleeves was also left untouched. Well, the old sleeves also didn't have any adjustment rings. That is, we simply replaced the old sleeves with new ones without any changes. Alright, so now I'm taking out the sleeves, unpacking the sealing rubber rings that came with the piston set, unpacking the rubber rings, installing them, and then installing the sleeves into the block. I also plan to install the pistons in place today. So we see we have 4 rubber rings, 3 thick ones and 1 thin one. Out of these 3 thick rubber rings, one of them is a different color, kind of purple. And it turns out that this rubber ring is installed closer to the crankshaft. That is, it's the very first one, like this. First, install the purple rubber ring. Well, then 2 black ones and the top thin one goes on top. I assembled the previous engine. I put it on sealant. Well, I don't know here. I'll take a look now. Maybe I'll also apply a thin layer of sealant. So I installed the sleeves and I also put the upper rubber seal on sealant. Well, that's because the block is already pretty old and there are still some defects, specifically in the seating area for the rubber seal. So I installed it with sealant, tightened it like this, and I want to show it in the clamped state. We see block 0. Block 0 goes up to about 1800ths, then block 0 again also reaches up to 1800ths, 0. Well, somewhere around 1716, I remind you. We should have this from 14 to 20. We also see 17. And 18. That's all. So I installed the sleeves. Yesterday I spent the night on it. Now I'll try. I unscrewed one sleeve at a time. Remove these clamps, insert the piston, and then probably I'll put the clamps back in place. Because I still have a lot of work to do with the engine. Before I install the cylinder head, there's still a lot of work to do. So I'll keep the sleeves clamped in place in a clamped state. So I want to briefly explain in a couple of words why the procedure of installing this particular piston took so long. So basically the oil pipes, or rather the oil nozzle, when you insert the connecting rod, part of the connecting rod rests against the counterweight and part of the connecting rod rests exactly against this pipe. So it feels like the oil nozzles should be installed only after the connecting rods with the pistons are already in place, and only then should the oil pipes be installed. I had to turn the connecting rod a little like this, rotate it and turn the crankshaft. Insert it and then only after that. Generally I'm unsure. I'll attempt it on the next one, which should be simpler due to the absence of counterweights. So the marks on the bolts, these were made when the rods were being worked on at the machine shop. The machinists made those marks there. Now I'll wipe them off with solvent and put my own marks. Here. Like this. So I'm continuing the assembly and now I'm working on the timing mechanism, figuring out the overall system. Here's a very interesting, I'll try to explain briefly. So we have the crankshaft and 2 intermediate gears are installed, or actually you could say 3. These 3 gears, they're all intermediate, and from them the drive goes further. Here is some additional equipment, and over there we have the camshaft drive. So what's special about this cover compared to the block is that it doesn't align in any way, meaning there are no guides, and as a result it moves around like this. But these 2 gears in relation to this cover are centered, meaning you can't move them. And it turns out that this cover needs to be centered in such a way that there is a thermal gap in these gears. like this, about 1/10 of a millimeter. I looked on the internet to see how all this is done, and I made 2 of these, how should I say, guides or jigs. In general, there are factory-made guides like these, but the system there is different. That is, an additional cover is attached to this intermediate plate, this cover, and then the cover itself is attached to this plate. To the guides, the diameter of these guides is 17.8, and it turns out that when you remove this cover, you need to screw into these places. In general, there are 2 such barrel-shaped guides, and they are simply tightened with a bolt. Temporary guides are installed, and some work is done with the block. The cover is removed, the timing mechanism is disassembled, but these guides are temporary. They cannot be removed, they must remain installed on the block. And only after this intermediate plate is installed during assembly, and only after all these bolts securing this plate have been tightened, only after that can you unscrew these temporary guides and remove them. I looked it up in the literature, found the number that should correspond to these factory guides, searched for them in stock, but they are nowhere to be found. Well, in general, I also looked on the internet to see what people are doing there, homemade solutions of this kind. There are various options. So, well, in general, I went the same way, machined 2 bolts like this and screwed them in. I installed this cover without sealant for now. It's meant to be installed with just sealant, no gasket. I screwed this cover on, tightened it, and installed these gears. I tightened them as well, just to check and see how everything will fit together. So, as we can see, here we have a gap of about 1/10, here the gap is also about 1/10, but this gear, it turns out, is not centered at all in relation to this plate. That is, it moves like this, that's the kind of movement it has. So, it needs to be tightened only after the head is installed, after the camshaft is installed, and it turns out you also need to maintain the gap. Here, 1/10, here 1/10. Well, as an option, you can just insert a feeler gauge here and here, and with the feeler gauges in place, tighten these bolts as well. That's what I'm working on right now. And I came to the conclusion that from several sources I've heard, you shouldn't grind these heads on a flat grinding machine. So the machinists told me that you can't grind it because then you can't adjust the gap. But I've also heard from other sources that you shouldn't grind this head either. So I haven't yet reached the point where I'll be installing the camshaft and checking, adjusting the gap. But as far as I can see, the amount of movement we have here up to the 4th and the intermediate one, let's say, to adjust the gap by 2 or 3/10, I think it's not a problem at all. Well, these are just my preliminary thoughts for now. When we get to the point where we install the camshaft, I'll be there already. I'll understand all this more precisely for myself when we get there, whether it's possible to adjust within such measurements as, say, 0.345 millimeters or not. But for now, I stick to the opinion that adjustment is quite possible. Why not? We have quite a large margin here when it comes to the mounting from the bracket. I also want to say that it's a very interesting system. The shaft is inside and oil is supplied to the shaft under pressure. There, each one has its own channel, and on this shaft there's a bushing on the gear itself, and oil is also supplied under pressure to all 3 gears. So it turns out that right here we have this kind of oil nozzle installed, and this is also an oil channel, and it has a drilling for each gear. So this is a very well designed, reliable GRN mechanism in this engine. So what am I going to do now? Now, you unscrew all the gears, remove this intermediate plate, but you also unscrew these guides, lubricate everything, degrease it again, apply sealant. I have a good sealant. It's the only one I use now. I really like it, so I apply the sealant. Well, then I install this plate, tighten it, put it in place, these 2 gears as well, tighten them. And for now I just set this one roughly to the middle position and tighten it just a little bit, barely at all. But then, as I said, it gets adjusted later, so I tighten it up afterwards. Next, I'll probably install the oil pump here, and then I'll move on to installing the cover, the flywheel, closing up the oil pan, and then I'll get to installing the cylinder head. I don't know when that will be. I think we'll get to the cylinder head in about 2 days, more or less. It seems like there isn't much work here, but since all of this is still unfamiliar to me, I have to really get into it, think everything through from the beginning, understand it, and only then start assembling. That's how things are with us. We're continuing the engine assembly. So, as we can see here, we have the oil channel. Here it comes out of the block, the main line, and it goes to one shaft. Here we have the mounting for this gear shaft around the circle, 6 bolts. The channel goes to the second shaft, and we also see the mounting, 6 bolts, and it also goes to the third shaft with the gear mounting as well. In this place. Here we have an oil nozzle, the one I showed earlier. So oil also goes here to the nozzle. Okay, we will apply sealant right here around the perimeter, and also apply a thin layer of sealant along the oil channel. That's it, so I'll degrease it and apply the sealant. Here, apparently, I have a small dent that formed when the block was being transported. Now I need to smooth it out with a small file. Carefully. So I installed the gears, tightened the bolts, applied thread locker, and just slightly tightened this one for now. I adjusted it as I mentioned before. I also installed the oil nozzle that lubricates these gears. So next I'll remove these homemade guides of mine, and then I wanted to install the oil pump. As for the oil pump, I took it apart to check what condition it's in, since the pump is old. I'll assemble it now, lubricate the gears with assembly paste, and I also removed the intermediate gear. It has this kind of wear on the bushing itself, and you can also see some scoring on the shaft itself. So on the previous engine I worked on, I also had to replace this gear. I think we replaced both the gear and the shaft there, and it turns out it's the same situation with this engine. We can also see that the lubricant goes through this hole directly from the oil pump. The lubricant enters this hole, then goes here, gets onto the shaft, and then finally reaches the bushing itself. So it turns out that the lubricant goes directly from the pump, it doesn't pass through the filter. That means the oil is unfiltered. Literally, if something gets in there, scoring starts right away. Here's the condition of the gear, and it's exactly along the channel where the oil passage is. So we've ordered a new gear and shaft, and I'll have them in a couple of days. Well, basically, I still have some time right now, so I have something to keep myself busy with for now. So, we'll wait. Now I'll assemble the pump, install this cover, install the pickup, and then we'll wait for the gear. So I've installed the housing and tightened it. It just goes on with sealant, without a gasket. So we see the housing without the oil seal. The oil seal is this large size, 180 by 205. So as we remember, during the last engine assembly I also struggled with installing the oil seal there. But the thing is, whether they come in a gasket set or separately, they come without a guide tool. That is, as some know, there should be a plastic guide with the oil seal, so you can easily put it on. So that basically it doesn't bend it like that. In that way, exactly. No matter how many we bought, and now we have a set of Erling gaskets, it comes with an Erling seal, but it's also without a guide. So what did I decide to do? I decided to install the cover first, and now, just like this, use my hands to fit the seal in, and then tap it in with the guides. Basically, this is a workable option. Sometimes I change seals on a Mercedes right on the spot in the pit, for example, on the engine. This way I fitted the spring, and I know for sure that the spring went in and didn't get bent. And now I'll carefully seat it all the way around into place, and that's it. So I installed the cover, installed the seal. Basically, it's a good working option, much easier to install than what I struggled with last time when I installed it without a guide. So that's it. The cover is tightened. I've tightened all the bolts. Here I screwed in the sensor bolt. So next I'll be installing the flywheel. The pressure plate and the disc, we are keeping the old ones. I cleaned them, installed a new bearing, cleaned the disc, blew it out, got it ready. Also cleaned and blew out the pressure plate, got rid of dust and dirt there, and I also prepared the flywheel mounting bolts.